Hi, everybody. I'm Steve. Thanks for having me here. I traveled the whole way from New York. I work for a company called Mozilla on this programming language called Rust. And so I'm here today to give you a little bit of talk about what Rust is about and to show you some stuff about writing web services in Rust. So why have a talk about Rust at a Java conference? Well, this is about JFuture, and Rust has learned some interesting things from Java and how Java approaches web services, and we have kind of our own sort of spin on things. So there's some connections here, and I'll get into them more a little bit later. Okay, this is our logo. It's a nice bicycle gear. And so first, the fun thing about being at a conference where you can't be sure everyone knows about the language you're talking about is I'm going to give you a little overview of the language to start off. So if you look on our homepage currently, it says this: Rust is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. This is also Ferris, our cute crab mascot. I have a t-shirt as well, but Ferris kind of sounds like iron, like Fe is the symbol for iron on the periodic table, and so it's kind of like a joke. But the problem with this slogan is that it sort of looks like this. Like all of those words don't really mean anything unless you already know what they mean. And that's a really bad sort of way to design a slogan. And part of this is because, you know, if you're working on a programming language, you want to talk about programming language features because you're a nerd who loves programming languages, so let's get into the details about what the language does. But that's not a great way to explain to like regular humans what something does. You don't want to tell people like the details. Like getting on an airplane is about traveling to another place. It's not about like you get to sit in a big metal tube and it goes through the sky. Like, you know, travel companies advertise based on visit a faraway destination. And so sort of what we're talking about lately with what Rust actually is Rust is a systems programming language designed to empower developers to write all kinds of fast, safe code. So originally, Rust was kind of developed to improve Firefox. And now, like, if you use Firefox, and I am in this presentation, so all of this stuff is actually being rendered via Rust code. So it's kind of got this low-level C++-y kind of like thing going on. But it's also, it feels significantly more high-level in many ways. And so we found that a lot of people who would maybe never write C or C++ have decided that they like writing Rust. So for example, I came from Ruby primarily, and Perl and some other dynamic scripting languages. And I did write C and C++ personally, but a lot of people who do Ruby are writing Ruby because they don't want to write C in the first place. And it's actually like hard to get people to contribute to the Ruby language since the interpreter is kind of written in C. But we're finding that a lot of people who are sort of scared of C or C++ are like interested in using Rust, and that's been kind of like interesting. So we have like all the way up and down the stack. Like I'm talking to you about web services today. My hobby project in Rust is writing an operating system. So it like really gives you the whole spectrum of different things. Additionally, we're pushing really hard on WebAssembly, so Rust is kind of also a language you can use in the front end of your browser as well, but I don't have time to talk about that right now. But like, it is the full spectrum, like front end of the web browser, the whole way down to OS level stuff. Before I show you how to write some web services, I want to show you a little bit of the features of the language so that you can kind of understand the syntax and what's going on. So let's look at some code. This needs to be bigger. Actually, I guess it's fine. So we have a tool called Cargo that lets you do all the build package management shenanigans. But the most important thing is hello world. So it's a requirement when you're showing someone a new programming language, you have to show hello world or else you get in trouble with the programming language gods. So this is what hello world looks like in Rust. We kind of have the curly braces and semicolons thing going on. Unlike Kotlin, we chose fn instead of fun for the function keyword. But you declare functions with fn, and then you have the name. Arguments would go in the parentheses, and there might be a return type. In this case, this doesn't return anything. And then println hello world. So you can, this is going to be really small, so you can't really see it, but it'll build and run and spit out hello world. Rust is like not exactly object-oriented, but can still feel like it sometimes. So we have these things called structs. And a struct is kind of like a class, except for it only holds data. So in this case, this person has one member, and that's of the type string. So they have a name with that string. But we still let you define methods via something called an impl block. So we can say, to implement onPerson, so here inside this impl block for implements, we say person has a method called hello, and you have this explicit self parameter, so this takes self by reference, and then prints out self.name, right? So this is kind of like interesting because instead of mixing the concepts of code and data into one thing called a class, we split them out. So sometimes you can have pure data structs that have no methods, but if you want to attach functions onto methods, you can do that. And for free functions, you just don't have the like impl block, you just have the function description. So anyway, this is a teeny little bit of the code and the way that some features will look like. Rust as a programming language has tons of stuff, but this is not really a talk about like giving you the language basics. We're going to talk about web service stuff, but I kind of wanted to give you this basics. Oh yeah, the other thing here. So if we wanted to make a person, you'd sort of do this kind of thing. So Rust is completely strongly statically typed, but we do really strong type inference. So let p declares a variable where you put the person into it, and even though I didn't give this a type annotation, Rust will actually figure out that that's a person. And this goes a little bit farther than, for example, I know Java 10 just added sort of a little bit of type inference. This will actually look into the future and see how you use your variables. So for example, if we took a function that took a person as an argument, and then we passed p to it, Rust can actually like see, oh, you passed this variable to this function and it has that type, and like figure it out backwards. So we have like really, really strong type inference, which is pretty cool. Anyway, that's enough about the basics. The last thing that people sort of talk a lot about Rust is that Rust does not have a garbage collector, and so this is true. Rust has no runtime or no GC. But you'll notice I didn't like allocate or free any memory specifically in those code samples. What happens is the Rust compiler figures out where your variables goes out of scope, and it automatically will like free memory for you. So you kind of get this feeling like you're using a GC language, but like not actually. And it also checks your references to make sure that if you have a reference to something, if it were to go out of scope and deallocate the memory sooner, then it'll say, hey, that's not actually going to work, and it'll tell you that doesn't work. So those are kind of like the big picture things about Rust. Okay, so why write web services in a language that's kind of a little more low level? My fellow core team member, Ashley Williams, posed this question in a talk recently, which is kind of funny in that the languages we use to build web browsers are often the languages that we use to write web servers. So like the fact that Firefox is now C++ and Rust, but like Chrome also is using C++, everybody thinks that's totally reasonable. But if I said that you should write your web service in C++, there are people who do that, but that's not like a thing that most of us generally would consider doing. And so it's kind of interesting to ask the question, like, is it a good idea to write something that's for the server that's in the same language as what you'd use for a client? And there's a couple different reasons why we found people are really interested in writing web services in Rust. And this is enough people that we actually spent part of the year with a working group. So like the people who work on the language, we actually spent a significant amount of time making Rust good for web services, and I'm going to talk about where that's at in a second. But sort of the number one answer is speed. And before I get into this benchmark, I want to point out that all benchmarks are stupid and bad. But I'm still going to show you a benchmark anyway because we're at the top of it. So this is really small, actually, and I don't think it gets bigger because this framework doesn't work that way. All right, so this is the Tech Empower benchmarks. I don't know if any of you have seen these before, but they're kind of a framework benchmark where people submit implementations of various web servicey things, and then every so often they benchmark it and they put up these graphs, and everybody gets to argue about how good or bad their favorite languages did or did not do. And so right up here at the number top, it's really small so you can't see it. Actix Raw, written in Rust, highest performance possible on the plain text benchmark. It beat out every other single thing, which is kind of interesting. And then below that is Go, C++, and then the fourth place is Wizardo, which is a Java framework I've never heard of, but maybe some of you have. Regardless, this is kind of why benchmarks are stupid, is because you'll notice that I said Actix Raw. So that's like using the framework, but also not really using the framework. And way down at it's actually off the bottom. Like number 11 or 12 is just plain Actix. So like there's already a little bit of weirdness going on there. But also, like, if you look at the difference between number 1 and number 2 on this list, so Actix Raw has 7,040,000 requests per second, and the second place one has 7,026,000 requests per second. So, like, are you really going to choose a language based on, like, an extra 20,000 when you're already talking about millions of requests per second? It's kind of silly. And likewise, with the speed thing with Rust, low latency is a really big thing too. So Actix also here has an extremely low latency of 0.3 milliseconds, like overhead on these things. And so, again, benchmarks are dumb, but these numbers do actually matter in the real world. And the primary reason why they matter is that efficiency is money. So a lot of people are sort of developing stuff to do web things in Rust because, you know, with the cloud, we hand Amazon a chunk of our revenue every single month. And if you can be more efficient with your resources, you can give Amazon less money than you normally would. Because I'm in the core team of Rust, I hear a lot about things that companies are doing. And there is a company that I know that all of you know that I cannot actually name that has Rust on one of every single of their servers. And they've already saved more than $10 million a year based on their previous like Python implementation of the thing that is on every single one of their servers. And that's because when you're the kind of company that has hundreds of thousands or millions of servers, saving 1% efficiency, you know, translates to a lot of actual capacity. And the other reason that we see people specifically choose Rust over the JVM, which does happen sometimes, is memory requirements. So because we have no runtime and no GC, you can get really, really low memory requirements for things, and that also translates to saving money. So for example, our equivalent of Maven Central, like Crates.io, the package management registry, it is written in Rust because we control it, and so we wrote it in Rust because we wrote it before it was even a good idea. But it uses 30 megabytes of RAM flat at all times, like megabytes. So you know that also can translate into saving piles of cache. So that's one reason people are really interested in doing these things. Another one is reliability. So Rust has like a pretty, we're not quite Haskell level type system, but we're like closer to Haskell. I know a lot of Scala programmers actually come to Rust and get a little frustrated because we don't have all the fancy stuff that Scala has, but we're like closer to Scala than we are to something like C. And so with this strong type system stuff, Rust really emphasizes getting your program right up front. And what that translates to in production is reliability. So NPM, the package manager for JavaScript, they actually run a Rust microservice to handle the rendering of readmes on their package pages. And their CTO, Siege, says something about like this: Rust services are never what triggers PagerDuty. So, you know, she really likes the reliability aspect because, you know, when you're dealing with operations, a lot of times stuff goes down and you have to like figure out why it's going down and spin something else up again. And they pretty much deployed a Rust web service and it ran for about a year and everybody kind of forgot it existed, which is like the best ops story possible. And so this kind of like strong reliance on static typing is something that, you know, you all enjoy on the JVM to a certain degree as well, but a lot of people who come from more dynamic backgrounds are, you know, really excited. Like when you're a JavaScript programmer, like any type system is amazing, right? So that's why TypeScript is doing so well. And so this kind of like approach to reliability is, you know, a big factor of why people do this stuff. All right, so I told you a lot about why you might want to do some of this stuff, but I also I love Rust, but it's okay if you don't. Like, I'm not trying to convince you that you need to follow my religion. And so, like, we're engineers. We're about discussing, like, frank trade-offs of what's good and what's actually bad. So I'm going to tell you a little bit about why Rust is kind of like a bad idea for web services right now. Because that's how you have to, like, actually evaluate making decisions. And I want you to be informed about the technology choices that you make. I don't know if you remember this old movie. It's amazing, Wild Wild West with Will Smith. But the biggest reason to sort of not choose Rust, and especially over JVM technologies right now, is maturity. So, you all have like decades of like reliability and tooling and practices and workflows, and like things change obviously, but like the JVM is one of the most mature development platforms that exists. And Rust has been stable for 3 years, and the ideal web stack is like gonna be just barely stable in like February. Like we're still a little teeny bit early on that. And so, it takes a certain kind of person or organization to be willing to sort of dip into something that's so new and relatively untested. You may have to like learn how to do certain things, and we don't have the same like observability, kinds of things that like the JVM is fantastic for. And so all of the various things really kind of boil down to this sort of like maturity kind of angle. So yeah, like you can do amazing introspection things on a process running in the JVM. You use GDB with Rust executables. Like it's like, stuff like that. And also I'm gonna be showing you some stuff that exists today, but also some stuff that's kind of like coming in the future. Another aspect of immaturity is that there is not like a winner yet. So I said earlier I come from Ruby world, so it's like pretty much everyone uses Rails, and then some people use something else maybe. In the JVM world, you all have like a number of web frameworks, but not like too many. This is like, I came up with this list off the top of my head, and then I realized that there was still like 3 or 4 more, but I didn't want to like make more bullets. So like there is tons of activity and people kind of writing their own web frameworks. And like since I don't really do a whole lot of JVM programming, as I've been watching the presentations today, when you talk about like different kinds of projects and the names of these technologies, I'm like, those are words. And it's the same thing with naming these web frameworks, like Iron, Nickel, Gotham, Rocket, Actix, Tower. Like, okay, those are all words. And at least like one of these is not really maintained anymore, and the second one was unmaintained and just got new maintainers, and some of the ones I left out are like not maintained at all. So, you kind of have to be like really adventurous in choosing the particular framework that you're choosing, and some of them also have additional drawbacks based on compiling for stable versus unstable Rust. So I haven't really talked about Rust stability, but we kind of have like the stable release and then the experimental release where you can opt into experimental features. And so like Rocket is one of the most popular web frameworks, and that's the one that NPM uses I referenced earlier, but it uses experimental features of the language that we like might remove any day. It's almost stable now, but for a long time it's been kind of using this like bleeding cutting edge Rust. And so when you're like, yeah, cool, use this new programming language, but also don't use the stable builds, use the ones with the experimental language features turned on, is like, not really a great like reliability production pitch. I'm going to be showing you some like an actual like web service in a little bit, and we're going to be using this Tower Web at the bottom there. Tower Web came out 4 weeks ago, and when I was preparing the code for this talk, I found 2 bugs in the framework, and I had to send patches upstream to fix them. So like that's kind of where we're talking about with ecosystem maturity. But that's also really like cool and exciting at the same time. Like this is a negative, but also sometimes a positive, right? Like it's really neat to be involved in something that's early and has a lot of energy, and you can do all these kinds of things. But it can be a downside. Okay, so yeah. Beyond that, I want to spend most of the rest of this talk showing you some like actual code for an actual sort of web service. So I'm going to change over here to this, and this is no longer needed. Here's the real thing. So Because I come from Rails world, the hello world of every web application is write a blog. So I have made an extremely minimal blog, and by extremely minimal I mean you can make posts, but you can't delete them. Because the deletion code looks almost the same as the creation code, and I'm just trying to show you what it looks like. I will eventually have a complete version up online, but I wanted to kind of keep it as minimal as absolutely possible. And so I'm going to scroll past all these use statements that bring stuff into scope, because that's not interesting right now. And I'm also going to scroll past this stuff and show you kind of the core of how this framework works. So this is Tower, and I should also mention I use VS Code, but another fun thing is that IntelliJ is actually arguably the best supported Rust IDE, and they've actually been developing a Rust plugin for IntelliJ and CLion, and it also works really well. I got this computer 2 weeks ago to replace my 4-year-old computer, and I forgot to actually reinstall IntelliJ, and I was like, oh man, I'm going to a conference where there's literally IntelliJ people there, but I'm going to use VS Code. But it's great. It's also kind of interesting talking to Java people, because sometimes when I show people look, you can write a web framework where, see this annotation that says get and then slash, that's the URL that maps to this function, and people are like, whoa, that's really cool, but you all use annotations a lot, in my understanding. That's something you're very familiar with. And so different Rust web frameworks do things in different ways, but Tower Web chooses this kind of attribute, is what we call them, instead of annotations-based approach. And so here, this sort of hello world, as I mentioned before, this impl block is how you define particular methods, and so each method becomes a route. But you'll also notice there's this additional impl web shenanigans above the impl block. So this is actually a macros inside of macros. So you have the annotation on hello world to generate the route itself, but then you also have the entire thing inside of an impl web block that'll actually generate all of the routing infrastructure for you. So eventually that will be unnecessary. In December 6th, that will go away, but until then we need it. Like I said, things move fast. So let me just show you this actual response happening. So if I spin up the web server, I built it before, so it just builds instantly because it doesn't even need to build. And then, hello world, we get something back. Super fancy. So yeah, so get with a slash will do this get request, and then we can create a new string, hello world. The fact that this is a string in double quotes, but there's also string from, there's 2 kinds of strings in Rust. It's complicated. You can talk to me about it later. Basically, it's sort of, the difference between a primitive integer and the class integer in Java. That's sort of what the deal is. We have the primitive string and then the class string. So we have to convert between them, and it looks weird, and people get confused, and they get mad about it. It's fine. OK, so let's talk about creating a new blog post. So in that case, this would be, look at how beautiful this blog is. You can tell that I'm a back-end person. There's 0 CSS on here. Partially because I wanted to keep it simple, partially because I find no CSS websites charming. Whatever, it's fine. So this particular page gets rendered through here. So this method is a little bit more involved. So we have our get post new, but in this case, the previous one had a content type of plain, so it would just return the literal text that we put here. However, this time we want HTML, and I'll show you at the bottom, but in this case, we're also saying that we want to use a template named posts new. So this particular framework has some interaction with handlebars, and so this is actually a handlebars template that I'm rendering, and that's how you give it the name, is with this annotation. And so in this case, we return this result of a response, and the response gives you the things that are going to get filled in with handlebars. So in this case, it's kind of arbitrary. I just wanted to show off how you would pass some data from your kind of controller-ish thing into the view. And so in this case, this title has a new post. And so if we look at, if I could actually click, this is kind of the handlebars template that renders this, right? So it's just some basic HTML, but we can interpolate stuff just like handlebars normally does. Okay, before I get into the interesting meat of it, which is when you actually create a post, and we're going to talk about databases and stuff, I'm going to scroll down to the bottom because I never showed you actually instantiate this service. So here we have this main function, and we pass in, so we create the service, we pass in our blog, and then in this case we're saying, hey, we want to use handlebars, and then we call run on it and we run it. So this is kind of how it gets put together. And then finally, when we're creating a post, this is kind of neat. So here, if we have a post request to /posts, there's this new post struct that's in here, and the framework actually knows how to take the query string, not really query string because it's a post, but the body of the post request, and serialize it into the data structure that we request. So this is kind of strongly typed, and it will only work if you pass in all the stuff that gets needed. And then finally, I want to show you a teeny little bit of the model code that actually does this. So Rust has this great library called Diesel that's used for SQL stuff, and I'm using just SQLite here because I wanted to keep it simple. But here, so for example, if we're trying to find a post and we pass in an ID, this statement, post.filter ID equals to post ID, grab the first post. This is actually a DSL that strongly types, represents a whole SQL query in the type system, which is kind of really ridiculous. And it's really cool, but the problem is that if you misspell things, the error messages, so if I say frist instead of first here, or I guess it was filter, so filter 2 instead of filter, when I try to compile this, I get okay, this error message is actually not terrible, but I've gotten type error messages that are 3 screens long. So that's the downside of having really strong static types, is that they can get really wild whenever you quit stuff, or whenever you mistype things. Anyway, I want to talk about one or two little more things before I'm done here, but I'm going to create a new post because that's cool. You can see this is now compiling, and it just takes a second. Rust is based on LLVM, and LLVM is not the fastest compiler in the world, so sometimes that happens. This is my cool post. Hey, JFuture. And we can make it. Cool. Blog stuff. It's done. There's some more stuff I could show you, but I don't have that much time. I want to cover one or two other things before I go down. So one of the really interesting things here is that we in the Rust world like to study other programming languages to see how they do it, and we steal the good stuff. So I don't know how many of you know this paper called Your Server as a Function. This came out of Twitter and is sort of the basis of the Finagle framework that's in Scala and has a Java interface as well. And so all that stuff that I showed you and all of the sort of core web service stuff in Rust is based around this thing called Tokio, which uses futures. We're at JFuture. It's a futures-based library. We've secretly been using futures the whole time to do asynchronous stuff. And so we directly imported all of this sort of from your universe because it's awesome. So good job. But kind of everything is based around this idea of futures. We also, the other half of it is that we kind of stole Node's concurrency model. So this is a diagram of what Node looks like. So you have the application goes to V8, and it passes stuff into the event loop, and the event loop executes stuff. And so Ashley, who I mentioned before, made this hilarious Rust version. So there is no runtimes, that gets crossed out, and there's futures, and they go on the event loop. So Rust's multi-threaded web service architecture is kind of this weird mismatch between the APIs of Scala and the runtime of Node, which is kind of interesting and cool. I could talk about that forever, but I only have 2 more minutes left, so I will not. However, I also want to talk a little bit about a thing that's coming that's cool in Rust's future, which is Async Await. So I was showing you all synchronous stuff, and that's also primarily because Diesel is a synchronous database API, so we don't have full async yet. But one thing we're really excited about in the future is Async Await. And this is kind of, in Rust case, so here we have async function hello world instead, and this would be fetching from a client, so there's await on the client connection. This is actually, even though you don't see any futures here, async await desugars into a futures chain, basically. Like it writes the chain of the futures for you, and then has a generator or like a coroutine that drives the futures to completion. So you get to write this code that looks really synchronous, but is actually like built on top of all those futures primitives, which is like really neat and interesting. Sadly, I have no more time to talk about that. So that's a little bit of an overview of like web services in Rust, why you may or may not want to do them, and some code examples. So thank you so much for having me.
Thank you. So we have a couple of questions.
Cool.
Yeah. So the first one about struct. And if you're going to declare struct and then write implementation across in different places in the code, so as I understand, you can write different impl in different files, right?
Yes.
So how can you accidentally overwrite some methods, or how you could understand?
So yeah, this is a good question. There's sort of a joke in the Rust world. The default answer to any question about Rust is the compiler yells at you. So if you can write an impl block in 2 different places in the code base, and that's fine. But if you write the same method, the compiler will say, hey, you wrote the same method like here and here. You got to pick one. You can't do both. So you don't get any sort of like magic overwriting. You get compiler errors. Yeah.
OK. So the next question is, what about using Rust binaries with Java?
So
via GNA protocol.
Yes. So Rust can pretend that it's C, basically, like it exposes a C interface. So anything that you can, like, anything that can call C can call Rust too. And that means that Rust does work with JNI. There's not a lot of great libraries for it, so it's a little fiddly. And there's also one other really ridiculous thing that I don't recommend that you do, but I want to tell you about. So someone wrote a WebAssembly to JVM bytecode transpiler, and then compiled the Rust regular expression engine to WebAssembly, and then cross-compiled that WebAssembly directly to JVM bytecode, and is now running the Rust regex engine like on the JVM. So don't do that, but you might want to like check it out because it's really cool. The real answer would be like use JNI and like be a real adult person, you know, unless you're trying to like have fun and be silly. But yeah, that's basically how it would work. You expose the C ABI, and then you call it through JNI.
Okay, cool. So we can use Spring Boot and then use Rust via GNI. Cool. Does Async Await use state machines like in Kotlin, for instance?
Yeah. So I've been reading up on Kotlin's implementation, and I don't know as much about it as I should. So if you want to talk about this, you should come talk to me at some point, because I would be interested in talking about it. But yes, so basically, in Rust, every individual future is like an individual type. And so the compiler actually sorts out like how you chain your futures together, and then turns that into a compile time state machine of how everything gets chained together. So yeah, it ends up after you compile away all the layers of abstraction, which LLVM is really good at doing, it basically boils down to a state machine that you didn't have to write by hand. And that's how it like does the stuff. Yeah.
Okay. So what about support industrial standards in Rust, like protobuf or some queues, APIs for them, and so on?
So support ranges from amazing to non-existent, depending on what specific thing that you're talking about. I know that gRPC has a pretty good like production usable thing already. Another thing is that flat buffers, which is like one of the successors to gRPC, they actually just added Rust support in mainline. So like the actual official flat buffers project gives you a Rust SDK. But yeah, there's also like cap and proto and like a bunch of that stuff that exists for sure.
Fair enough. And why Mozilla like start using Rust and develop Rust?
Yeah. So basically, Mozilla was like looking at their C++ code base, and they were like, this is really difficult to maintain. And specifically, the CSS rendering engine, we tried to make it multi-threaded twice, but it was just too complicated and too full of bugs. And so we also looked at security vulnerabilities, and like over half of the security vulnerabilities in Firefox boiled down to C++ is a sharp tool, and sometimes you cut yourself. And so Mozilla had like an R&D division at the time, and so the idea was to sort of do this like moonshot project. Like, what if we could actually make the browser significantly better by making a programming language that would be just as fast as C++, but would not have those kinds of bugs. We'd be able to eliminate the security vulnerabilities, and we'd be able to make everything parallel really easily. And so it turns out that that took about 7 years of development, but we did it. And so that's kind of like why they did this like really strong investment. And this also leads to one really hilarious Firefox bug. I forget the specific issue, but someone filed a bug 10 years ago on Firefox, and recently that component got rewritten in Rust, and when it got rewritten, the bug got fixed, and so they closed the bug out, 15-year-old bug. And so people were like, imagine if you went back in time when they originally filed that bug and said, cool, we will fix this bug, but we're going to go make a whole programming language first and then rewrite part of the browser in it second, and then your bug will get fixed like over a decade from now. And that's kind of really silly. But yeah, that's the reason why.
That's cool engineering approach, okay?
Yeah.
So, and good continuation, and the last question about comparing two sites, dark side and light side, maybe?
Sure.
Rust and Go.
Yeah,
So-
everybody loves doing the Rust and Go comparison.
Yeah.
The way that I like to think about this personally, and I should also say this, so the person who manages the Go team at Google also lives in New York City, and like we get lunch once or twice a year. Like the people that work on programming languages basically all talk to each other and like vaguely like each other. We don't really have the same mentality as like the people on Hacker News who are arguing about which language is like better or not. The way that I think about the two languages compared to each other is basically this. Go is like a scripting language that's getting closer to the metal. It's like going downward. And Rust is like a low-level programming language that's reaching upward. And so this means that like they have very different goals, which means they make very different decisions. So for example, Rust needs to have generics because efficiency and competing on speed with C++ is like our #1 priority in many ways. It's actually our #2 priority. Safety is the first one, but the second one is very close, is speed. And so that means that we needed generics. We couldn't afford a runtime or garbage collector. Go, on the other hand, is trying to make a language that's great for web services. And so those things are less of a super importance to them. And so they've been able to forego generics and have a runtime and do kind of cool stuff with it. And that leads to a much simpler language that's like a lot easier to program in, but it will never be as like fast as Rust is. And that's totally fine. It's just about what your language values. And so yeah, that's kind of the way that I think about them, is like Go is like high level going down, Rust is low level going up. Sometimes they're a little similar, sometimes they're a little different. We actually have a number of companies that are using Go and Rust in production together. So for example, Dropbox has a Go front end and a Rust back end to their data storage services. And Linkerd, which was originally written in Scala, Linkerd 2.0 is actually written in Rust and Go both. Same thing, the control plane is written in Go, and the data plane is written in Rust. So they're actually like weirdly complementary sometimes too. It's not even like an either or. Sometimes it could be both.
So thank you. It was the last question.
Yeah.
And thank you for a great introduction to Rust.
Thanks so much.